Life and existence, a theoretical look. I think looking at all these two questions, I think we need a lot of scientific background knowledge to really look into this question. So I will show you just roughly how this involves is philosophy, mathematics, physics, chemistry, biochemistry, biology, and medicine. I will just show you how this involved, and it may take a lot of time to really understand something, but you need this knowledge in order to try to look into this subject. So philosophy, you can see there are 5 main branch in philosophy. In this, you are dealing with concept of knowledge, and there are some other branches like this here. Philosophy of history is where history is progressing to a specific end, whether the history. And you can see philosophy of mathematics is talking about the ancient symbol, what it means in mathematics. And some other branches like philosophy of mind, so talking about what mind is and does other mind exist, so like artificial intelligence, all this kind of thing. Like a philosophy of religion, the study of God, and some recommendation of religion practice. Philosophy of science, can science really explain everything? This is mathematics. This is just a branch of mathematics. You can look through this easily in the web, like algebra, calculus, and geometry, Ukrainian, non-Ukrainian, all these things. This will really help understand quantum mechanics and also the Einstein's relativity, like a probability theory. Some other thing I taken from the book, mathematics, you can see trigonometry, derivative, integration, beta function, Taylor theory, all these things. This is needed when you are dealing with physics and some physics chemistry. So these are just a list from a book, and you can see, for example, they have a topology, probability, number theory, and integration and functional analysis, trigonometry, plane geometry, spherical geometry, all kind of different coordinates. And these are some other books, and you can see number theory, algebra, geometry, limit, continuity, and topology. And you can see differentiation, integration theory, power theory, and probability is also important. Some other application, numerical computation, like computer, all these kind of things, sociology, psychology of learning math. So I have to go through this quickly. This is math, for example, specific for science student. You can see Taylor theory, you can see elliptic integration, you can see Fourier series, metric, vector, tensor. And this for physics, and you can see vector. For physics, more important is you will understand the Einstein relativity easily. Vector, tensor analysis, and coordinate system, like spherical coordinate, polar coordinate, all these coordinate. And you can see infinity theory, Taylor expansion, whatever, and complex variable, real number and complex number, determinant metric, and then you can see differential equation, integration equation, gamma function, all have application to understand some of the theory. Bessel function, this is more important in the physics. Fourier transform is more important in engineering. Fourier transform, integral equation, calculus variation, and for mathematics, for engineering, and it's more important the differential equation, then integration equation, and the Laplace transforms, Fourier transform, vector analysis, tensor analysis, and so fluid dynamic, all this, so computer, complex number, and complex integral, all this, and Fourier series, Fourier transform, and numerical analysis, computer probability statistic is more important for engineer. And then let's see the branch of the physics. I will give you later on a simple physics textbook. So classic mechanics, statistics mechanics, electrodynamics, you can see what this involves. Modern is quantum mechanics, relativity, particle physics, atom, molecular, energy level, and spectroscopy, cosmetic, all these things. And these are instructions for the physics. In general, you deal with kinetic, and then you deal with first law, Newton first law, second law, and third law, and then you start deal with rotation and torque and motion in a plane, and then you start dealing with kinetic material, and then you can see the fluid dynamic and the conservation of energy, and then heat, thermodynamic, then material, solid state, physical phase transition, all these things. And the wave, you gradually start to talk about electromagnetic light and electricity and magnetism, and eventually talking about quantum physics, quantum mechanics. So these are the general things involved in physics. Now the chemistry usually is organic chemistry, deal with carbon and hydrogen, nitrogen, oxygen. Inorganic chemistry deal with all kind of metal, all kind of in periodic table, all the elements. Physics chemistry is deal with physics and chemistry, like spectroscopy, or quantum chemistry, that kind of thing. And then analytic chemistry is just some kind of measurement, measure how much certain compound is in certain solution. Biochemistry more involved in medicine and life. So let's see, physical chemistry, you study gas, liquid, solid, and their transition, and you study the chemical bond, what does it mean, chemical bond, and molecular